In this lesson, we're going to be exploring surds. More specifically, we're looking at binomial expansion of surds. A quick introduction to binomial expansion. Binomial expansion, or the binomial product, can be represented by this little expression here on the board, underlined in green. Now, a binomial product is when you have two factors multiplied together that are made up of a sum of numbers. So here we have A and B. They're added together and they're being multiplied by C and D. Now, this is a rather complicated way of writing the answer. You've got AC, AD, BC, BD. All that pretty much says is you need to multiply each number by every number in the other bracket. So A times C, and that's where the AC comes from. A times D, that's the next number, that's where that comes from. B times C, and B times D, and those BC and BD there. So that's all that means. Now, some people like to remember this as the rainbows, and that's what happens when you draw those lines on there, is you start to get a couple of rainbows happening. What we're going to do is we'll look at this in a basic form. Instead of dealing with complex numbers or surds or anything, we'll just look at it with whole numbers to start with. So here we have 3 plus 5 multiplied by 9 minus 2. Now most of us, according to our BODMAS, would deal with this by doing the brackets first. We would add those together and we would have 8 multiplied by 9 minus 2 is 7, and that would get us 56. Seems easy enough, but what happens if this 5 is actually an x and you don't know what that is? That makes it a little more difficult. So we're going to keep them as whole numbers and we're going to solve it using the method above. So using our binomial product. Alright, let's rewrite it down here. We're going to have 3 and the 5 multiplied by the 9 minus the 2. So 3 plus 5 times 9 minus 2. According to our rainbows, our first number in the first bracket needs to be multiplied by the first number in the second bracket. So we're going to have a 3 times a 9. Then we need our number in the first bracket multiplied by the second number in the bracket. So that is going to be plus 3 times negative 2. Plus, next we need to multiply the second number in the first bracket by the two numbers in the second. So we're going to have 5 multiplied by the 9. And that's going to give us 5 times 9 in that bracket, plus that number again, the 5, multiplied by the last number over there. That gives us 5 times negative 2. That's all rather long now. Let's simplify it down. 3 times 9 is 27. 3 times negative 2 is a negative 6. 5 times 9 is 45. Plus 5 times negative 2 gives us negative 10. So what we have here, just using some quick, positive and a negative makes a negative, positive and a negative makes a negative. So 27 minus 6 gives you 21, plus 45 minus 10 gives you 35. 21 and 35 give you 56. That's the same answer as we got above by just multiplying the two numbers together. So we know this method works, and we know that's how we do it. It is rather long and complicated, but we need to be able to do it because we cannot solve things any other way. We've looked at adding and subtracting surds together, and we know that it's the same as adding and subtracting like terms. You can only join apples with apples and oranges with oranges. So if we had, and for example, in this bracket here, we had a square root of 5 and a square root of 7 in the bracket, we cannot add them together first without destroying the accuracy that holding the square root signs keeps. So we need to do this longer way of multiplying each surd together to get this long answer, but still highly accurate. This isn't a binomial product, but it will provide a great stepping board into dealing with multiple surds together. Okay, the steps are going to remain the same though. We have this number outside the bracket. Remember, there is a invisible multiplication sign in there, and we have a root 5 and a root 7 in there. So what we need to be able to do is grab the first one and multiply it, and multiply our root 3 by the root 7 as well. So let's have a look. Square root of 3 times the square root of 5 I'm going to do that under the 1/3. That's using our rule of joining them together. Then we're going to have a plus the square root of 3 times 7. Okay, simplifying those multiplication, we have a 15 plus a 21. Now we cannot join those together because it's a 15 and a 21. That's like having some apples here, yet having the oranges over here. We cannot say we have 20 oranges. So we need to do something about this. Can we simplify those? Is there any factor that is a perfect square that goes into 15? No, I can't think of one. Is there any that goes into 21? No. So that is as simple as our answer can become. Have a look at another example. Getting a little more difficult. We've got some coefficients this time, but the steps remain the same. We just need to remember that whole numbers by whole numbers and surds by surds when multiplying. So here we have 2 root 11, and we're going to multiply that by 3 root 11. Then we're going to have 2 root 11 again, and multiply that by negative 5 root 2. Alright, give myself some more room. 2 root 11 times 3 root 11. We might write this out the long way to make sure that we don't miss a step. There's our first one, and that is added on to the 2 root 11 again, multiplied by the negative 5 root 2. Alright, let's multiply these out. Whole number by whole number. 2 times 3 gives us 6. Surd by surd. The square root of 11 times the square root of 11. Now, this is kind of like saying the square root of 11 squared. It's been multiplied by itself. And remember, those are the opposite operation of each other. So that becomes just an 11. So we've got 6 times 11 plus, down the bottom, we've got the 2 times the negative 5. So that gives us a negative 10 in that bracket, multiplied by surds by surd. So we have the square root of 11 times the square root of 2. So that is the square root of 22. And we will close that bracket off. Okay. 6 times 11 gives us 66 plus minus 10 square root of 22. And we're almost there. Just got to fix up this little symbol in the middle and give our answer to be 66 minus 10 root 22. And there we have it. There is expanding some brackets using surds, but not quite binomial expansion just yet. Okay, binomial expansion. Looks imposing. The steps remain the same as before. We just have one more multiplication to do. Alright, let's draw on our rainbows. First by first and first by second. Then we have second by first and second by second. Now we multiply along those lines and write down the answer for each. Okay, so multiplying along the first red line, the little rainbow, we have square root of 7 multiplied by 3 root 2. So we have the 3 root 2 multiplied by the square root of 7. I might break this up again to make sure we don't miss a step. Alright, we add that on. Now we're going to do the big red rainbow. We have the square root of 7 multiplied by negative square root of 3. Then we have the little green rainbow. So we have the square root of 5 multiplied by 3 root 2. Add that on. Now the big green rainbow, we have the square root of 5 multiplied by negative root 3. So that's quite a bit of work involved in this. And let's join them together. The top line. Now remember, whole numbers by whole numbers and surds by surds. And even though there isn't a number out the front of square root of 7, we can pretend there is a 1 because that doesn't change it. So we have 3 times the square root of 14 plus negative square root of 21 plus 3 multiplied by the square root of 10. That's the two surds multiplied together of 2 and 5. Then we have, I'm going to have to go underneath here, negative square root of 15, because the two surds of the 5 and negative 3. Give myself a bit more room here. Let's finish it off. Can any of those be simplified? 14, there's no perfect square in that. 21, a 10, 15. No, none of them are the same, so we cannot add them together or take them away like terms. What we can do is we can clean up these double signs that are starting to appear. So we can have 3 root 14 minus 21 plus 3 root 10 minus the square root of 15. Now I should have went down a little bit more so I could write that in one big line, and I might do that now just to show you what it should look like. So 3 times the square root of 14 minus the square root of 21 plus 3 times the square root of 10 minus the square root of 15. And there is our final answer after a binomial expansion. Now this is a lengthy process. I'm not going to lie and say that it's not going to take very long, but it is rather easy if you keep track of everything you do. Okay, last example. Let's bring this question back here. We've got a whole bunch of different numbers. We've got whole numbers, we've got basic surds, and we've got surds with coefficients. So we need to be careful with how we do this. First off, I'm going to put my rainbows in. I'm going to do first by first and multiply first by second. Then I'm going to have second by first and second by second equals. Now I might keep these in colour just to make it a little easier to see. We have the little one, 3 times the square root of 5, plus our big green rainbow of 3 times negative 3 root 2. Okay, dealing with our red rainbow now, we have plus 2 root 10 multiplied by the square root of 5, plus our big one, negative 2 root 10 multiplied by negative 3 root 2. Getting lengthy again. As I said, I'm not going to lie, these do take a bit of time. Okay, let's start simplifying. 3 root 5 can stay as 3 root 5. Now we have 3 times negative 3 root 2. So a positive times a negative is going to give us a negative. 3 times 3 is 9, and the square root of 2 stays the square root of 2. Plus, now that should have been a negative in there, which means we have a negative times a positive, so we're going to have a negative here. And we're going to have 2 times the 1, so the 2 out the front, and a 50 under the square root sign. And we have a negative times a negative to give us a positive. 2 times 3 is 6, and under the square root sign we've got 20. Alright, still a bit more work to do just yet. 3 root 5 is as simple as it can get. 9 root 2 is as good as it gets. 2 root 50, that can be simplified. What I'm going to do, I'll highlight that, underline that in green, and go over the side here and say that we're going to do that as a little side project, so to speak. Okay, so the 2 stays, and we're going to split the 50 up into 2 factors, and I'm going to go ahead and just go 25 and 2, which means we've got 2 times the square root of 25 times the square root of 2. Square root of 25 is no longer a surd. The most accurate way of writing that is as a 5. And then we've got root 2, so that ends up being 10 root 2. Going back over to our real answer for this question, it was minus, and instead of 2 root 50, we're going to say that it is 10 root 2. Alright, the last one, 6 root 20. Same sort of deal. Is there a number that can go into 20 that is also a perfect square? I think there is, so we're going to do this one as a red side project. So we're going to have 6 root 20. Now the 6 stays out the front, and I'm going to split the 20 up into 4 times 5. 6 times the square root of 4 times the square root of 5. The square root of 4 is no longer a surd, that is 2 times the square root of 5. So that gives us 12 root 5 as our little sub answer for that one. So over here goes plus 12 root 5. Alright, now what do we start to notice? We start to use another previous skill of adding together and subtracting surds, and we've got a square root of 5 and a square root of 5. And we have a square root of 2 and a square root of 2. So we need to add these together. We've got 3 root 5 and another 12 root 5. So we have 15 root 5. Then we have negative 9 root 2's. Take away another 10. So we've got negative 19 root 2's. Alright, and finally, that gives us our solution. After all that work, all we get is 2 surds with a couple of coefficients. A couple more examples. I just want to make sure that we are used to looking at them. This example here, it is a perfect square of a surd. That is, it is a binomial product because it's 2 terms added or subtracted together, multiplied by another 2 terms added and subtracted together, but they are the same in this case. So we have the square root of 7 minus the square root of 5, and that squared sign means that it is multiplied by itself. So it's the square root of 7 minus the square root of 5. And we go about this the same way we'd ordinarily do. Square root of 7 times the square root of 7, square root of 5, and the square root of 7. Then we're going to do the second by the first, and the second by the second. What we're going to do, we'll start a little bit lower, make sure we've got enough room. The square root of 7 times the square root of 7. Whenever you multiply the 2 surds together that are the same, your square root sign simply disappears. Then we have the big red rainbow, and that is square root of 7 multiplied by negative root 5. So that's going to give us a negative square root of 7 5s are 35. Alright, now we have the little green rainbow, negative root 5 times root 7. Negative by a positive is a negative, and that is going to give us another 35. This time we have 5 times 7. Negative times a negative is a positive for the big green rainbow. And when you multiply 2 surds that are the same number, you just get the number without the surd sign. Alright, pulling our answer together, we have 7 plus 5 to give us 12, and then negative 35, negative root 35, sorry, take away another root 35, which gives us minus 2 root 35. Having a look at the square root of 35, it is a large number, so there may be a perfect square that can go into it. What do we got? 25, that's not going to work. 16's not, 9 is not, 4 won't, so that is as simple as that answer is going to be. Last example, and this is just a little special case that I hope you keep an eye out for. Alright, having a look at the defining features. 3 root 11, 3 root 11, 4 and 4. The only difference is there is a plus in the middle of one and a minus sign in the middle of the other. And let's see what that does for our answer. Okay, now we have first by first and first by second. And we have second by first and second by second. We need to make sure that we multiply along each of those lines. Okay, 3 root 11 multiplied by 3 root 11. That is our first one. 3 root 11 multiplied by negative 4. That's going to give us a minus sign. 3 root 11 times the 4. Now remember, it's not negative 4 because I've taken account of that and put the minus sign out the front. Okay, plus. Now little red rainbow is 4 times 3 root 11. Big red rainbow is 4 times negative 4. Now I write negative 4 this time because I wrote a plus sign and I didn't account for it straight away. Okay, 3 times 3 is 9, and when you multiply 2 numbers that are the same under a surd sign, that square root sign disappears, so it becomes just 11 minus 12 root 11. Then we have plus 4 times 3 is 12 root 11, and 4 times negative 4 is minus 16. So what we have, 9 times 11 is 99. Now we've got 2 surds that are the same, so we can join these together. They are like terms. We have negative 12 root 11s plus 12 root 11s. So that actually gives us no root 11s at all. So we can say, just in our middle here, plus no square root of 11s. And we have minus 16 on the end. Pulling that together, 99 minus 16 gives you 83. So what I referred to at the start of these defining features being the first two numbers being the same, the second two numbers being the same, the only difference being a plus and a minus sign in the middle, is the fact that two of your numbers are going to cancel out. And if that doesn't happen, you haven't done your multiplication correctly. And you need to account for that and have this in the back of your mind when you see that you're trying to do binomial expansion. They're the same numbers, just different signs. Okay, that about wraps it up. Thank you for your time and good luck.